pretty common nowadays. Computer-aided design softwares, CAD softwares are pushed a lot onto, technical students. Like I learned some of those in high school, and then they're pushed more in college, but there's a disconnect in the actual manufacturing where we're learning CAMs, computer-aided manufacturing softwares. I know I took a co-op here when I was an undergraduate at the University of Tennessee, where I worked for 15 months with a company that I learned the CAD softwares they use, but I was kind of kept out of learning the CAM and programming softwares they use, and actually the logic and how you actually machine and manufacture different components. So coming across this course through the University of Tennessee, and just with the outreach that these programs have, I was able to get my feet wet and actually get years worth of secondhand experience in a week. And then once again, I didn't have to go and actually become employed by a company to get any sort of formal education out of it, because that's what it takes in industries. If you want to learn a CAM software, if you want to learn how to run a machine, you have to go to that whoever makes that software, whomever makes that machine, and actually get formal training, which is thousands of dollars. It's insane how difficult it can be to get enlightened into this world. And this program actually allows you to get an online, or rather a software-based component and a hands-on component. It's an opportunity that you wouldn't be able to find anywhere else. The online component played a big role in just the understanding of how each of the programs we were running to machine the particular components that created the whole air engine assembly. So going through the Fusion 360 tutorials was great at just getting an understanding of what exactly we'd be doing and looking at when the machine tool is actually running. I thought the most interesting topic in the online training was the machine dynamics and how complicated that is, and how it plays a role in the capability that you have to produce a particular component, and the ability or the proficiency you have in creating said component, and how all that ties in. It was just a complete other realm that I had no prior experience to. So during the in-person component of the ACE training, we produced and assembled a reciprocating pneumatic or air engine. So we created the flywheel, the block. We were given a piston and a couple of other components that we were able to decorate even, and then assemble them all with the necessary bushings and assembly components, fasteners, in order to produce a complete working mechanism when introduced to an airline. So it was really neat to see how well other people's worked, and kind of just the differences between the same program. I learned from machining the different components and assembling it just how detail-oriented you need to be for your design, and the intent of the manufacturing has to tie all in together to have a working final product. And also just the complexity that I wasn't quite aware of prior to entering into this realm. So the air engine that we made during the ACE course was a great mechanism to show the usefulness of what shop air, just compressed air, and how it can actually power different things, that people see every day. So one thing that I related to was just like locomotives, how in locomotives, there's steam that drives these essentially pneumatic engines that then transfers that energy into rotational energy, and locomotives move rather. So this component was a great example into how engineering design and manufacturing mindset can be used to get useful applications out of maybe difficult to use energy sources. So a really cool aspect of the ACE in-person component was that we actually machined a polymer component that was 3D printed, which was an idea that I hadn't been exposed to previously. But the valve body that we actually used in our reciprocating air engine had internal features that you couldn't reach through a conventional sense. So you couldn't actually subtractively manufacture this component in its entirety. So that's an amazing, process to take components that you couldn't solely make through an additive process, and then additionally you're using less material. So machining additive preforms is a new process that will be amazing in trying to meet these energy goals that we've set for ourselves and reducing the amount of material waste that, future designs are going to have to be developed by. So the instructors were great because they were greeting a body of students that all, had different backgrounds, but essentially the same level of expertise in the machining world. So if you were to try to get the same, learning experience out in industry, you're going to be, maybe shoulder to shoulder with people who have, decades more experience than you. So it's really kind of hard to, ask questions and not look kind of silly. But when you're greeted with, a body of students that all kind of have the same entry level of expertise, it was nice to be greeted kind of where any question was a valid question because no one else in the room really, would have had the answer, and it wouldn't have been, low-hanging fruit in a sense. So it was great to be in an environment where everyone kind of had the same questions, and that the instructors, that everyone kind of knew that this was a learning environment and that no one had previous experience, which isn't what you find maybe out in industry, where in this sense, egos were set aside, which was great because we were actually able to ask kind of goofy questions. So the one activity I probably enjoyed the most was just the little friendly tournament we had in assembling the air engines the fastest. That was really fun to see people frantically trying to find, the right bolts to put in these holes, because, we had different coarse thread and different length bolts and different bushings that, allowed the reciprocating air engine to work. So you kind of had to be mindful of what went where and in what order everything went. So the little, NCAA bracket tournament we had going on, especially because when I had taken the course, it was March Madness, and unfortunately UT had just lost. So it was nice to actually have a tournament. We were actually, there was a chance of winning. So it was a lot of fun doing that. But also just hearing the machines run for the first time was just kind of an awakening experience. When you hear that face mill run across the low carbon steel, just I was like, wow, we're just the incredible work that those machines you can have done in the right hands it was incredible. Yeah, so I was part of the first kind of guinea pig group for the first inaugural ACE session, and I was also lucky enough to be a part of the courses that took place at MDF, and I was able to see students that I hadn't gone through the course with that were actually asking questions that are the driving research topics in the manufacturing world today, just through seeing, the 1 to 2 hour sessions that Dr. Schmitz puts on, that discussing machine dynamics and the complexity of modeling these machine tools and driving their efficiencies higher across, different models of machines.